Okay, sixth graders. So now we're going to talk about triangles. Okay, we're going to talk about the different kinds of triangles, the features they have, and why those are important. Please, hey children, I'm trying to record a lesson here for my students. Could you please stop yelling about your Grey's Anatomy episode? Thank you. Okay, back to triangles. Okay, sorry about that. Anyway, back to triangles. Okay, so this should be pretty much a review for you. Scalene. So scalene triangles, what you should know, they are triangles that do not have any congruent sides. And you should see the definition of congruent on the Google slideshow that we prepared for you that is in the Google Drive. So that just means that the sides are not a mirror image of each other. They're not the same. Okay, so the scalene triangle, the sides are not the same. They're not equal to each other. So if you look here, you'll see like this side, this side, this side, they're not equal to each other. They're all different lengths. Okay, so you should be able to see that on that scalene triangle. The isosceles triangle, they have two congruent sides. So this side is congruent with this side. That's what those little lines mean there. They're the same. And you would also notice that here is a little right angle. I don't know if you saw that or not. So we have two sides that are congruent, they're equal in length, and they have a right angle. Equilateral triangle, that is a triangle that has all congruent sides. All the sides are the same length. That's why we have our three little congruent lines. And so that's a very nicely proportioned triangle. Then you have the acute triangle. All the angles within that triangle there are measuring less than 90 degrees. Okay, so we mark those there, showing that each of those angles is acute. Okay, meaning less than 90 degrees. An obtuse triangle means that one of the angles is going to be greater than 90 degrees. Okay, only one of the angles in a triangle can be obtuse. Why is that? Take a second and think about that. Why can only one of the angles in a triangle be obtuse? I am hoping that you said because the angles in a triangle add up to 180 degrees, right? So if one of them is greater than 90, 180 minus 90 is 90, right? So not two of them cannot be greater than 90 because 90 plus 90 is 180. That would mean the angles would add up to greater than 180, and you can't have that because the angles in a triangle all add up to be 180 degrees. Okay, so that's your obtuse triangle. And then we have what's called a right triangle, and that is a triangle that has one right angle. Okay, so there's a description of the different kinds of triangles for you. Okay guys, we're gonna go over this hierarchy real quick. You have this in the notes also. So this is on triangles. So it just goes through the different kinds of triangles we went through on the last slide, and the properties of each one: the scalene, the right, the isosceles, and the equilateral. I'm not going to go over the properties because we just did that. What you need to remember though is the formula for the area of the triangle is area is equal to 1/2 base times height. And I want you to also remember that, so on the right triangle, you see the right angle, right? So that is going to be where the height is going to come from, and your base is going to be on the bottom. The other triangles, you don't see the right angle, do you? I mean, possibly here on the scalene, you might say that's the right angle. But so on the other problems like these, with these other triangles, what you're going to see is a line that comes down and a right angle drawn for you. That is where you're going to know is the height and then where the base is. Okay, so you have to make sure that you're looking for the right angle to get where the height is. Okay, there could be times that they put it outside the figure, so you might see something like this outside a figure somewhere, and they might say, and then you could see it here. I have only seen that a couple of times on some problems, but I have seen it, especially in parallelograms or rhombuses from time to time. Even though you're supposed to use the diagonals, you might think it's a rhombus, but they're saying it's a parallelogram. So you just want to keep that in mind, that you're looking for that right angle to indicate height. and it's very important with the triangle that you get that in your head, because like I explained earlier, that formula is half of what the parallelogram formula is, so they kind of go together. Okay, so I want you to keep that in your head when you're solving these. So I wanted to go over that hierarchy there, and remember and show you that you need to look for them drawing the right angle, because it might not always be obvious like on the right triangle. Okay, so just keep that in your head. We're gonna pause for a minute, and then we're gonna go through a couple practice problems together, and then you're gonna move through the rest of your lesson. Okay, thanks. Okay, so we're going to do a couple triangle examples here together, okay? So number 10 here says, a triangular plot of land has the dimensions shown in the diagram. What is the area of the land? So what is your formula for area of a triangle? So I'm hoping you said area is equal to 1/2 base times height. We're looking at this triangle. So my area is going to be 0.5 times 30 times the right angle, right, is indicating that that dotted line is your height, times 20. So my area is going to be equal to 15, because 0.5 times 30 is 15, times 20. Area is going to be equal to 300 kilometers, 300 kilometers squared. Okay, does that make sense? Okay, now number 11 says the front part of the tent has the dimensions shown in the diagram. What is the area of this part of the tent? Okay, so I'm going to pause. I'm going to wait. I want you to pause the video now. Please pause. And you figure this out. Okay, I want you to start with your formula, plug in your values, do your multiplication, and have your label. Okay, I'm going to pause for a few seconds and let you figure that out. Okay, so I'm hoping that you have areas equal to 1/2 times base times height. Area is equal to 1/2 times 8 times 5. Area is equal to 4 times 5. Area is equal to 20 feet squared. Does that make sense? I hope so. Hope you got 20 feet squared for this one. Okay. Pause. Okay, let's take a look at number 12 here. Okay, number 12. So, the 6th grade art students are making a mosaic using tiles in the shape of right triangles. Each triangle has legs that measure 3 centimeters and 5 centimeters. If there are 200 tiles in the mosaic, what is the area of the mosaic? Now, when they say legs, they're telling you that you can use that as the dimensions for your triangles, as your height and your base, okay? Because that leg can, and they're also saying that it's a right triangle, so that is indicating to you that that leg can be measured as your height, okay? So I want you to take a minute and see if you can figure out the total area of that mosaic, okay? Pause your video, please, and try to figure that one out. Okay, so what you should have had is area is equal to base times height. The first thing you had to do is figure out the area of one of those right triangles, right? So area is going to be equal to 1/2 times 3 times 5, right? So area is going to be equal to 1.5 times 5, right? So if I put that in my calculator, 1.5 times 5, I'm going to get 7.5. So each triangle has an area of 7.5 centimeters squared. Now, how many triangles are they using? Well, they're using 200 of them, right? So I need to take my 7.5 and multiply that by 200, and I will get a total area of 1,500 centimeters squared for that mosaic. I hope that's what you got when you pause the video, okay? All right, so let's get rid of this. Isn't this so fancy? Yeah, I just discovered this little fancy tool. All right, last one. Monica has a triangular piece of fabric. The height of the triangle is 15 inches, and the triangle's base is 6 inches. I'm going to write that. I'm going to write what I know. I know that the height of Monica's triangle, height, is equal to 6 inches. And I know that, oh, I'm sorry, I messed that up, didn't I? Whoopsies. It says Monica has a triangular piece of fabric. The height is 15 inches. Come on, Mrs. Eccles, get it together. 15 inches. The triangle's base is equal to 6 inches. Monica says that the area of the fabric is 90 inches. So she's saying area is equal to 90 inches squared. They want to know what error did Monica make? Well, what error did she make? Take a minute, see if you can figure that out, okay? Pause your video. What did she do wrong? See if you can tell me. Okay, I hope you said that 15 times 6 is equal to 90. But that would be using base times height for your area formula, which is the area for a quadrilateral. We're not dealing with a quadrilateral here. We're dealing with the triangle. So Monica should have used the formula area is equal with 1/2 base times height. So what she didn't do was multiply by 1/2. If she had, then she would have had her area of 1/2 times 15 times 6, which would have given her an area of 45 feet squared, which would have been the correct answer. So Monica, womp womp, she used the wrong formula. Okay, there's one more thing I want to talk about, and then we're going to end this video lesson. So, what if you had a triangle? Here's my beautiful triangle for you. Okay, right triangle. And the height of this triangle was 20 feet. And the area of this triangle was 180 feet. So the area is equal to 1/2 base times height. And the area of this triangle is 180 feet. And I don't know the base, but I know the height is 20 feet. Can I figure out the base? I hope you're saying yes to this, because you will have problems like this, whether it be for a triangle or, rectangle, square, rhombus, whatever. They're going to give you problems like this where you have to then figure out the base or the height or the length or the width or the side, and they give you the area. And you can totally do this, guys, because you just finished up your lessons on algebra and solving for a variable, and you know how to do it. Okay, so we're going to do this one together. So what we have to do here is we need to first simplify the right side of this equation. So I'm going to keep my left side of 180 equals 1/2 times 20 is what? 10b. 80 equals 10b. How do I isolate b? What am I going to do? 10b, what's that operation? I hope you said multiplication. Yep, you did? Great, super, very nice. You can probably tell from this video I really miss teaching you guys in person. So how do I undo multiplication? What is the inverse operation that we should be using here? Division. Yes, totally, division. So I'm going to divide by 10 on this side of the equation. If I do that, I must divide by 10 on this side of the equation. Okay, so that's going to give me b isolated on this side, and that's going to give me 18 on this side of the equation, right? So then I should check this, don't you think so? To make sure that I get the correct answer, right? For my area. Okay? So, let's check that out. So, if area is equal to 1/2 BH, area is equal to 1/2 times 18 times 20. Area is equal to 9 times 20. Area is equal, is 9 times 20 180, guys? Is it? It is. Look at that. So I should add a square on that, are correct. We got it. Okay, so I just want to make sure we ended today's lesson with solving for a variable, so you kind of had that refresh in your brains too. Okay, don't forget, reach out to myself or Mr. Sloganov if you need any assistance at all whatsoever. We're happy to help assist you, and we hope you're all doing really well, and we hope to see you soon. Okay, thanks guys. Bye.